I want to put an idea into your mind. I'm going to vibrate the air using my voice, and your ears will convert that vibration into electrical impulses to be processed by your brain. And if that's working, then everyone here is thinking about elephants. Yeah? Good. Now, unfortunately, Chris, he's shown on the slide in blue and red. He couldn't share the experience with us. He didn't hear the word elephant. Chris has a hearing loss. In fact, all of the people on the slide here have a near complete hearing impairment, and for that they've been fitted with a cochlear implant. This technology allows deaf people to access speech by converting vibrations in the air, or sound, into electrical signals that are delivered directly to the hearing nerve. Unfortunately for Chris, he's not getting the same performance that we expected like the others. So for that reason, we've seen Chris in the clinic and done a range of tests on his device. And one of the results is showing us that something is impeding the flow of electrical current from the implant to the hearing nerve. The research that I've been doing shows that that can be the case in up to 10% of the patients that we see. So on the bottom left there, you can see an example of this abnormal growth in impedance over a 5-year study period. That's contrasted against, in blue, what we'd expect a normal, stable level of electrical impedance over the same study period. So I'll give you a bit of background to this. When the cochlear implant is surgically inserted into the inner ear, the immune system mounts a response and forms a shield of scar tissue around the electrode, shown a schematic there. So you can see a blue layer. That's a normal response. But sometimes this immune response is too strong and it's lasting for too long. So in cases like Chris's, we're having difficulty stimulating the hearing nerve because of this thickened shield of scar tissue. Now, I predict that events in the past, things like infection and even loud noise, can bias the immune system so that it's more reactive to events in the future, like cochlear implantation. I'm testing that prediction in the lab by analysing immune cells inside the inner ear. The research takes us a step nearer to understanding the differences between these patients, even before they're implanted. The approach that I'm taking to this is to consider that our histories are remembered by the immune system, and that's Chris.